Welcome guys to this new tutorial of Blender and Geometry Nodes. In this video I'm going to show you how to animate freehand curves. After the explanation I'm going to show you two practical cases like writing with cream on a cake and a funny example of a painting like an intro of Walt Disney. So let's get started. I'm working with the Blender version 4.0.2 and the concept behind this effect is this. We need to create some curves like this, but I want to have a single input attributes, so an animation from 0 to 1 to create an effect that can create and show this curve, starting from this curve as the first, next the second curve, and next the third, and so on. But keep in mind, it's important to maintain the correct sorting of this curve, because otherwise if I draw a word, for example, and I fail in some of the letters, you have to recreate from scratch the entire curve. Or otherwise, another technique is separate these curves in a collection and change the sequence of the curves by their name to be able to have the correct sequence of animation from the first to the last curve. Now, to test this effect, I prepared one curve with a length of 100 millimeters. I need to go to the editing with the tab key, press A, duplicate with the Shift D and move a little bit, and I'm going to move this point with a G and Control pressed to go here to have 500 millimeters. Select this one, Shift D another time, and move these on the X-axis until 1000 millimeters. So in this moment we have three curves, and remember the making of this curve. This is the first, then I duplicate it to create the second and the third. So the indexes of these curves are these 0, 1 and 2. Okay, this is very important for our freehand effect. Now we can go to the plus menu, General, Geometry Nodes, and click the new button to create the new Geometry Nodes modifier. Press 7 to see the orthographic view, focus on these test curves, and now we can dive into the trimming effect. So first of all, I can resample the curve using the length and not the count, so I can export this value. For this effect, don't use the count or the evaluated socket, because if you use the count and you set 10, for example, you would have here 10 points inside this space and 10 points inside this space, and we don't want this. We want a common distance between all the control points of all the curves of this object, and to do this we can use the length, export the length here, and we can set a number of 5 millimeters, for example. So to create the effect on our curve, we need another input attribute, so press N and go to the length, set it as a single value and set for a default, and click the plus button to create another input attribute like the animation, and this is a factor subtype from 0 to 1 and it is a single value, and we want to get the animation of this trimming effect on these curves from 0 to 1. To do this we can add a trim curve node, but look at this, what it happens if I decrease the end. I'm applying the trim effect at the same time on all these curves, and we don't want this. We want to distribute this end in a better way, and to do this I'm going to show you two ways to do this effect. One is better than the other, so in this way you can choose the method that you need for your project. This is the first method. So we have here three curves. So if you imagine a range of our input animation attribute, so an animation from 0 to 1, we want to distribute this animation along these curves. So if we divide each index of this curve by the number of the total curves, what do we get? We get 0, 1, 2 as the indexes. The number of the curves is 3. So if I divided each index by this number, I get 0, 0.33 and 0.66. As you can see, I can use this point here as the start point for the trimming. So this interval from 0 to 0 0.33 can be the interval of the trimming for the first curve. After this this point, so 0.33, I can start to trim the second curve in this interval between 0.33 and 0.66, and in this interval of number from 0.66 and 1, I can use this interval to trim the third and the last curve. So this means that for each curve I need to have a different minimum and maximum interval of values to be able to have the correct trimming remapping between 0 and 1. So you can see from this point and this point we have 0.33 and 0.66, but I need to remap this range in a range of 0 and 1 because the end trim socket in this trim curve goes from 0 to 1, and I need to do this operation of remapping for all these curves. So to do this I need a map range. I can import the group input node and link the animation in the first value. It's obvious. The last 2 min and 2 max have to be from 0 and 1 because I need an interval of values from 0 to 1, so I can link these results here. But before linking these, because otherwise we lost these curves, we need to correct these two elements for each curve. So as I mentioned before, we can get the index. If you want to be sure, we can link these in a domain size, in a spline domain to get 0, 1 and 2, and we can divide this number by what? By the domain size node, linking this resample, changing this to the curve because we want to know the total number of splines. I can link these to these. In this way, if I press Shift Ctrl and click to the trim curve and then to this divide and go here to the spline, you can see the same values I wrote here. And now we need to set the minimum and the maximum for each curve. So for the first will be from 0 and 0.33. For the second will be 0.33 and 0.66, and for the third 0.66 and 1. So this interval, as you can see, is exactly what? The division from 1 and the number of the total curves, this step. Okay, so I can duplicate this node, set 1 and divide it by the spline count here, and now we know that 0 is the starting point for the first curve. Okay, as you can see in the spreadsheet, 0.33 the starting point, the minimum starting point for the second curve, so the minimum, and this number is the starting point of the third curve. So I can link these into the from min, and I need to add what? The step between these two intervals to get the maximum values that will be remapped in a range from 0 to 1. And now if I link these to the result and increase the animation, as you can see, I have, if I drop for a moment the viewer, I have the first curve, the second curve, and the third curve. And if I set here 0.33, you can see only the first curve. The second in this moment has an end trim of 0 because in this moment 0.33 is the starting point for the second curve. Now this way has an issue, that is this. So imagine that you want to linearly animate this input attribute from 0 to 1. So you want to see a smoothed increasing of all the curves one after the other. But you can see if I increase this number from 0.33 and 0.66, the speed of increasing of the curves increases. So if you can look, if I increase linearly this number, you can see the first curve has a lower speed, then the second an higher speed, and then the third an higher speed again. So to fix this problem, I need to tweak this start and end interval of each of these curves in such a way as to allow me to increase linearly this attribute and have the same speed of increasing for all these curves. So for this reason I do not use this technique that I will leave in the file that you can download from my Gumroad page. I can select all these nodes, Ctrl J, F2, animate, trimming, of the curve quite right. If you want to simplify this workflow a little bit, you can also change this divide to a multiply and link directly this dividing, because this is exactly 1 divided by this number, so you can have the same result in this way. I can use H to collapse, and this is one method. So the next method is more efficient and more correct for our purpose, because I want to have the same speed for all these curves. So again, we are going to add a trim curve node, link the geometry with the Alt pressed and right button, link this to the end of the geometry. And now the second idea. So I will delete the annotation and now think in this way. What I want is to take these intervals, these previous intervals, and shrink or extend these values, these intervals, proportionally to the length of the curves. So what does it mean? It means that the entire length of this curve that you can see is 10 plus 5 plus 1, so 16, 10 plus 5 plus 1. We need to correct the starting and the end point of the map range of the remapping values of before to have the correct start and end interval for the first curve as a part of this 16, this length as another part of this 16, and this length of another part of this 16. The sum of these elements needs to be 16. So to do this, we can use a perfect node, so the accumulate field, and I can show you the result of this node. So if I press Shift Ctrl and click on the trim curve and then on this leading, selecting here the spline, it's obvious, and adding a spline length node that gives me the length of each curve. I can link here the node. You can see these in the spreadsheet. I have 0.1, that is the length of the first curve. Next we have 0.6, so the sum of first curve and the second curve, 0.1 plus 0.5. And then we have the total sum of all the length of these three curves. But if I link the trailing in this result, you can see we don't have the result as before. We have 0, then 0.1, then 0.6. So we have a shifting of the sum of the length starting from the first curve or the second curve. So if you move the mouse on this leading socket, you can see the running total of values in the corresponding group, so the sum, starting at the first value, and the second socket is the same but starting at 0. So if I write here the result of the leading, we have 0.1, 0.6 and 1.6, and the trailing is 0, 0.1 and 0.6. As you can see, we have a shifting for each ED, so the 0 for the first and the second curves. We have a shifting of these values between the curves, and as you can see, these are exactly the intervals we need. So the proportional number between these numbers here and the total can give me the correct values in the map range that we used before in the first method. So I can move these nodes a little bit. We can see if I link the total value here to the viewer, I get the same result for all these curves. And this is very important because for each element, for each curve, we need to make some calculations. And the calculation is this: a division between the trailing. So this is the trail and this is the leading. I can link the total here. I can duplicate these another time to be able to divide the leading by the total. And why this division? Because since we are going to use an animation value like this, we need to have a start min and start max value in the map range of our workflow between always 0 and 1, because here in the value we have this attribute. Another way could be not divide these values but multiply this animation socket, so the group input animation socket here, by the total length going in this value and delete these two dividing operation. It's the same. In this case, I will leave these to divide. I link these to the from min and from max and link the animation here. And linking this result here in this point, you can see the correct speed of all these curves while the animation of these input attributes. And why this? Because I expanded the speed of the first curve and I shrunk the speed of the third curve thanks to these proportional numbers. So in this way I have an interval from 0 to 1, where from 0 to 0.08 and 8 we have the space to show this length of the first curve. Then we have near 0.525 the end of the second, so here we have the interval values to have the start and the end of the trimming of the second curve, and for the rest we have the interval numbers for the third curves. Indeed, if I link this dividing output, so the leading divided by the total in this viewer, you can see the values of the ending of the map range, so 0.088 for the first curve, 0.525 for the second, and obviously 1 for the third. And in this way I get the correct same speed for all the curves of my sequence. We can drop the viewer, select all these nodes, Ctrl J F2, animate trimming of the curves, and voila, this is the correct method I will use in this project. We solved the problem of the speed of all these curves, and now we can transform these from a curve to a mesh, adding other 3 input attributes, so an object like the profile. This way we can use a line, a star shape, or whatever you want. Then we can add a scale to scale the radius of all these control points in a common way, or if you prefer you can manage the profile. So if you want to leave the profile as is, you can adjust this scale value that will be applied on all the 3 axes of my mesh, and we can set 0, for example, default 1, and we can set 1 here in the scale, is a float number, not subtype, and select a single value because we don't need to have an array of values, 1 for each point. Now we can add a group input, take the profile and get the object information, leave these to original, link these to a transform geometry node because we can use the scale to scale our object before going in the profile curve. Set fill caps, select all these nodes, Ctrl J F2, make the mesh, and this is very easy to do. Now let's create a profile like a circle, a simple circle, Shift A on the viewport, circle like this, S to scale a little bit like this, Ctrl A to apply the scale, select the curve and select in the profile this new Bezier circle, and we can rename it in a profile and curves. Now we want to have a freehand style, so we don't want to have this piece, this effect at the start and at the end point of each curve, so it's not a good result to see, okay, like this. And for this we need to rescale the radius of our control points inside this curve, this resampled curve. So I move this a little bit, and we need to add here a set curve radius node, and I will show you 2 ways to do this effect, one better than the other. It's obvious the second is better than the first, but I will show you both. I set a standard value for the radius to see the original value of the radius. Now if I press Shift Z, you can see the wireframe, and if I increase a little bit the length of the resolution to 10 millimeters, for example, you can see this. What I need is to have a smoothed shape like this, okay? And to have a smoothed shape like this, I need to start with a vector like this to be able to go inside a float curve node if I want to change the shape, but initially I want to start with a linear increasing of the values, okay, from 0 to 1, okay, like this, considering the radius values. And to be able to get this result, we can start to think this. I can say I have a curve, I have a length for each control point of this curve here. Each of these control points has a length starting from the start point of the curve. So for this we have 0, for this we have 0.1, for example, 0.2, etc. And the indexes of these control points are 0, 1, 2, etc. And here we have 3, 4, 5, 6, 7, 8, 9, and 10. And here we have 0.8, 0.9, and 1 length. So knowing these values, what I want is to have the effect of this range from 0 to 1 as a scale of the radius for a group of starting control points and ending control points. So for this example, these elements here and these elements here, from 0 to 3 and from the 7th to the 10th. And because we are talking with the distance and length, we can say if the length of these points is less than a threshold, so in this case 0.3 for example, I want to multiply the radius by values from 0 to 1, considering a range from 0 to 0.3, my threshold, remapping in a ramp from 0 to 1, okay, because 0.3 is the length of my curve, but I need to remap this range of values in a range from 0 to 1 to multiply the original radius by 1 from this point to this point and decrease the radius up to 0, going down to the 0 index, or starting from 0.7 and going to 1 in this case for the length. And to get the same group of elements and control points in the end part of this curve, we need to add a different question. So here we have numbers below 0.3, below or equal 0.3. Otherwise, we need to get values from what 0.7 and 0.7 is equal to the total length of the curve minus the threshold 0.3. So the input attribute that we are going to add in our group input. So this is the new minimum 0.7 and 1, the total length of this curve. And we will remap this range in a range from 0 to 1 in the same way as this. So let's make these. Let's add the spline parameter because we need to ask if the length of each control point is less or equal our threshold. So we need to go here and add a new smoothness. It's a float number, subtype known, default 1 for example from 0, and this is a single value. We can set 1 to have an initial value here. We can add the group input, link the smoothness here. So if the length of the control point is less or equal this threshold, we need a switch here. We need to add a map range as described before to remap what this interval of values from 0 to the threshold itself, linking the length of each control points, it's obvious, and getting the correct 0 to 1 range. And this is the true condition of this switch. The false condition of this switch is a duplication of this map range, linking the same length of each control points, but starting from a different range. So the 0.7 and 0.7 is the spline length. So I can link the length of the spline, and all these control points have the common value of this length because they are in this curve. Okay, so for each of these control points we have the same result, the same value. I subtract what my threshold, that is this smoothness, and I can use this value as the minimum, and the maximum, it's obvious, is the length, the entire length of the curve. And in this way I can have two ramp here. One is for this group of elements and one is for this group of elements. And now I can link these to the false and link these to a multiply, because I need to multiply this scale value by the actual radius of the curve, because I can modify in edit mode this curve and change the curve of each control point as I want. So not the resampled control point, but the control points I made manually. So I can link these to the radius. You can see this result, and this is because you can see we didn't flip the range from 0 to 1 in this part of the selected point. So we need to invert the 1 and 0 to get the opposite effect for the last points. And now if I decrease a little bit, you can see the correct effect we need. Now we can link this output before going inside this set curve radius in a float curve to change the shape, because in the input we have a range of values between 0 and 1, and we can change the shape as we need. So if I decrease the length of the resolution to 1, and we can rename it in res length, it's a better name, as you can see I can move the shape to get the correct shape of the curve. And now I have the same result, as you can see, for all these curves. Why? Because I played with the length of each control point for each curve. So the 0.1, 0.2 and 0.3, I have the same values here, always here in this curve. Even these curves are longer than this curve. So this technique works, but there's a limit for this, because if I increase the smoothness of this curve, you have this strange behavior. I delete the annotation to see better the issue, and you can see if I set the animation to 0 and increase a little bit, you have this strange behavior. And why you have this behavior? Because we have here a switch, so we have a wall between this method and this method. So for this reason, I'm going to show you the second method that is more efficient. And however, I can select all these nodes, press Ctrl J, F2, smooth radius at the start and end, quite right. Now I move these a little bit down, and the other technique is this: use the factor. So I add another set curve radius, I link the same geometry from the out of the trimming effect and link these to the curve to mesh. I increase to 1000 these, and I increase the animation to 1 and increase the resolution length another time. Now, as you can see, for each curve we have a factor. A factor is a number from 0 to 1 for each curve. So from these numbers we can make a ping pong effect. So in this way we can get an effect to the starting and the end point. So we can have this result, and this result here. And to do this, it's easy. You can add a spline parameter, get the factor, add a ping pong mathematical operation, and divide the same value of 0.5, because I remember the ping pong is a threshold. So if you use 0.5 in this point, you will have a decrease in values, a decrease in linear values. So if you are here in this point, you need to go back to 1 here in this point and then going down. And to do this, we need to multiply by 2 or divide by 0.5 this result, so the output of this node. And in this way you can have the correct ramp here to 1 going down to 0 here. Now that we have the correct factor values, we can use here a clamp value to limit these values in a range from 0 to 1 and link this result to this radius. But before, we need to multiply by the original radius of our curve and link this to the radius. And look what happens. You can see a big issue here, because you can see the total width of this radius. So the values of this radius are the same, one here and 1 here, okay, this width. But as you can see, the longer the curve, the wider the effect becomes. So in this case, you can see we don't want these angles here, but we want the same angles, because we need to have here an effect like these and these. So we want to have the same angle for all the curves. So to have the same angle, it's easy to do. We need to multiply this value before clamping by what? By the length of the curve itself. So if I take the spline length and multiply this length by this result and link these, you can see we have the same angles for all these curves here, here and here. And to see better this result, I'm going to increase the scale of this object, and if I increase, if you can see here we have the same angle for all these curves. Why? Because I proportionally and linearly increase this value here of the 1, so this angle, okay, this value, by the length of each curve. So this curve has a length of 1, I have 1 by 1. If this curve has a length of 5, I multiply the 1 by 5. And in this way, if I mute for a moment this ping pong, you can see the factor is multiplied by the length and can give us the same angle. Now, after these nodes, we need a last thing. So we want to clamp this value between 0 and 1, and to do this we need to divide this value that is different for all the control points by what? By the smoothness that we want. So if I add a group input another time and link the smoothness here, what I get is this result. So I decrease a little bit the scale to see better these effect, and if I set 1, you can see if I divide each of these control point output from this output here by the smoothness itself, I go over 1 here in this clamp, and if I go over 1, the system will give me always 1 as the result of this mathematical operation. And remember, the concept is always have a range of values between 0 and 1 to work well in your workflow. As you can see, we can't have numbers over this range. It's impossible. And if I increase or decrease the smoothness, I can have a different stretching of the effect. And why this? Because as you can see, if I increase the smoothness, I have a division that gives me a lower number here. So a lower number here is equal to, say, a lower number here and a lower number here. Okay? If I increase the smoothness, if I decrease the smoothness, I would have a higher number here and a higher number here, because a number divided by a smaller number can give me a height result here. But because we have a clamp value, it cuts all these values over 1. And in this way, the problem described before, so this problem, we haven't this problem, because if I increase this smoothness, I'm not going over 1, and I haven't the issue of before. And if I decrease the animation to a lower number, to see the result here in this first curve, you can see the correct number of radius got for each control point in a correct way for the first curve and for the other curves in the same way. As I mentioned, for the first method, we can link this result here in a float curve node and link this value in the multiply if we want to change the shape of our effect. I delete the annotations, select all these nodes, Ctrl J F2, smooth radius at the start and end, and voila. And now you can use this technique to draw what you want. In this case, I have only 3 curves like this, and I can go in the edit mode and change the radius of each of these elements in a separated way to get a different result. If I increase this radius, you can see this, or I decrease this, and I can scale and rotate to have a different result of effect on these curves. And for the last part, we can add a material in our group node, plus input material. This is a material socket, and add a set material. Add a group input another time and link the material to the correct socket. Last thing before jumping the practical cases, I can show you how to change this group input to use not an object like the curves, but use a collection of curves to have a different sequence of curves. So to do this, we need to add two input attributes. One is a check, use collection, and this is a boolean input, single value, plus input, and this is the collection, and needs to be a collection of curves. It's obvious. I need to change the type in collection, and here near the resample curve, I need to ask me if this is true with a switch, and if this is false, I want to use the original geometry and link these to the resample. Otherwise, I want to use this collection, and I can link the collection info. And because I don't want to have instances but curves, I need to link these to our realize instances to get the physical objects inside this collection. With this check, these separate children, because I don't want the output of this collection info as one single object, and link these to the true. So in this way, I can go in editing of this object. But before, I forgot to rename in a correct way these two objects. Sorry for this. This is the correct profile, and I can drag this profile out from this collection. This is the curve object, this is the profile, and now with this curve selected, I go in the editing with the tab key. I can select this curve, press P to separate, so to create a separated object in the outliner. The same for this curve, press tab to exit from this editing mode, and you can see we have three curves. And look the sequence of this curve by the name. Now I have the first, the second, and the third. Okay, so the first, the second, and the third. And now if I create a new curve like this, like a Bezier, because I want to use a collection of curves, so I need another object to apply the geometry node modifier, not apply the geometry node on one of the curve of the same collection. I can rename it in curves by collection. I can add the unassign geometry nodes modifier. I can delete the modifier on these curves because I don't need them. Now I selected the new curve, check the use collection, select the collection, and I can set a value like before, like this, and select the same profile, and you can see the same result as before. And now if I decrease the animation, I have the correct selection of curves based by the sequence of the curves inside this collection. And if I want to invert or change the sorting of these curves, I just need to rename the curve as I need. And now I can change the control points as I want, rotate, scale, or extrude another control point here and decrease the radius to have the specific radius to the end of this curve. And if I select the curves by collection, all works perfectly with only one input attribute. So let's jump in the practical cases. Okay, this is the project used for my intro, and as you can see we have a scene called cake, and this contains two collections, one for the cake project and one for the concept described before in this tutorial. And you can see we have the same example of curves, so you can test your curves as you need. Here we have our geometry node workflow, and if I hide this collection and show this cake collection, you can see we have here a room, then we have the table and the plate made in geometry node with this little workflow, the cake, and we have a camera that follows a curve as a path, tracking an empty object used for the focus while the entire animation. And while the entire animation, you can see we have here a first curve where I applied a particular material to simulate the shader of the cream. Next, we have a second animation with this object that is made by a custom geometry node setup, adding next a curve tilt geometry node setup to create a more realistic shape of the cream, as you can see here in this point, in this control point. And finally, we have the third animation, so the curve with the words of the intro. And it's obvious I can go in the edit mode and change this point as I need. And remember, if you failed the sequence of drawing letters of these words, you need to recreate from scratch the curves, because from what I know, Blender hasn't a way to resort the curves inside a curve object. So an alternative is to use a collection of curves separating all these curves. If you want more detail about the geometry nodes workflow applied to this object here and plate, you can download this project from my Gumroad page. And we also find another scene in this file, so the scene of drawing, and this is the project of the Walt Disney. Also in this case we have a camera pointing on this paper, we have an area light, we have a single piece of paper, and as you can see, I applied a particular shape for this writing. I applied also a noise geometry nodes setup to create a little bit of noise around the curves to get more realistic effect, and I applied a particular shade to simulate the ink of the original effect from the Walt Disney. As you can see in this case, if I go in the viewport shading preview and press tab on this curve, you can see if I press Shift Z to see the wireframe that I have here on high resolution, and with N you can see I have a different radius for these two control points to be able to change the effect of this animation. And that's it. Thank you guys for watching this video. I hope you like it, and I hope you will use this technique as an alternative of the great Grace Pencil tool of Blender. If you like my work, please subscribe to my channel. Don't forget to check the bell icon to get all the notification of my videos, and see you to the next tutorial. Bye!